Welcome to the Deep Dive for Factory English, Episode 5. Today, we are going to talk about a very common topic on the shop floor, changeover. And to really set the stage for you, the listener, imagine a massive manufacturing facility, right? One that generates millions of dollars a day in revenue.
Oh, yeah, a huge operation.
Right. Now, imagine someone just flips a switch and the massive machines grind to a dead halt. And suddenly that facility is burning through thousands of dollars a minute without producing, a single thing.
Wow, yeah.
That terrifying, wildly expensive pause is exactly what we are decoding today.
It really is the silent killer of factory profitability, but, there is a cure. And to understand both the problem and the cure, we're going to unpack a highly specific piece of industry text today.
Exactly.
If you are an English learner navigating the manufacturing field, this is crucial. We aren't just looking at definitions here. We're looking at the reality of the shop floor.
Absolutely. So to give you a rapid, high-level summary of the material we're exploring, it's fundamentally about why factories are forced to stop their machines, switch from making one product to another.
Right.
We look at how this pause in action, this downtime, costs the business money. And then we explore a globally recognized Japanese method called SMED, which was designed to take a process that, usually takes hours and crush it down to less than 10 minutes.
It is an absolute operational revolution. And to give you the full context, we are going to read the entire source text for you right now, verbatim, from start to finish.
Yeah, I'll set up the problem with the first half, and you can bring it home with a solution in the second half.
Sounds good.
Here is the text. In manufacturing, a changeover is the process of switching a machine, production line, or work area from making one product to making another. During a changeover, production must stop so workers can adjust equipment, replace tools, reset machine settings, or prepare new materials. For example, if a factory shifts from producing plastic bottles of 500 milliliter to bottles of 1 liter, the molds, machine settings, and labels may all need to be changed.
Exactly.
This downtime is called changeover time. The longer it takes, the less time machines spend making products, which reduces efficiency. All right, your turn.
Okay, picking up the text. This is where SMED comes in. SMED stands for Single Minute Exchange of Die, a method developed by Japanese industrial engineer Shigeo Shingo. The goal of SMED is to shorten changeovers dramatically, ideally to less than 10 minutes, a single-digit number of minutes.
Right.
The key idea behind SMED is to carefully analyze all the steps in a changeover and then, number one, separate tasks into 2 groups. Internal tasks, which can only be done when the machine is stopped, for example, removing a mold, and external tasks, which can be done while the machine is still running, for example, preparing the next mold nearby. Number 2, analyze all the steps in a changeover carefully. Number 3, convert internal tasks into external tasks wherever possible so preparation happens before the machine stops. And number 4, streamline and simplify the remaining internal tasks, for example, by using quick release clamps instead of bolts, standardizing tools, or using preset adjustments. By applying SMAD, manufacturers reduce downtime, increase productivity, and respond faster to customer demands.
Awesome. So to really internalize what is happening here, we need to look at the anatomy of that opening situation. It all hinges on one highly specific anchor word, right?
Yeah.
Changeover.
Yes, and for an English learner, it is vital to distinguish this from how we use the word change in everyday life.
Right. Totally different vibe.
Exactly. In conversational English, you change your shirt or you change your mind. It's casual. But on the shop floor, a changeover is a noun. It is a massive, highly coordinated physical event. You are transitioning an entire production environment.
You don't just change the machine. You execute a changeover. And the text uses the word switching, which it gives me this great visual of flipping a heavy lever on a train track to send a massive locomotive in a completely new direction.
That is a very accurate visual. And notice the physical spaces where this switching happens, right? A machine, a production line, or a work area.
Right.
These are distinct environments. A machine is a single piece of equipment, but a production line is a sequence. It's the series of workstations where components are assembled step by step. The product flows down the line.
Yeah, and a work area is even broader than that.
Exactly. It could be a quality control zone or a packaging area. Understanding these physical spaces is step 1 in mastering factory English.
So when that switch happens and the production line stops moving, we hit a concept that I actually want to push back on for a second.
Oh, really? Okay.
Yeah, because the text says production must stop, and it calls this downtime. Now, in a factory setting, downtime is always treated like a dirty word. It's like the ultimate enemy. But wait, isn't some downtime necessary? I mean, machines need maintenance, right? They can't just run 24/7 forever without breaking.
That is a very fair point, actually, and it brings up an important distinction. There is planned maintenance downtime, which is healthy and necessary to keep the factory alive.
Right, like an oil change for your car.
Exactly. But what we are talking about here is changeover downtime. During a changeover, the machine isn't broken and it isn't being repaired. It's perfectly healthy, but it's silent.
So
No products are being made, yet the factory is still paying the electrical bills, they're still paying the workers, still paying rent. It is pure lost potential.
Okay, that makes sense. It's the opposite of uptime, when the machines are humming and generating cash.
You know, visualizing this changeover downtime immediately makes me think of an analogy. To me, a changeover is exactly like a pit stop in a Formula One car race. Oh, the pit stop. Okay, expand on that a bit.
Well, think about it. The race car, which represents our factory production, is flying around the track. But eventually, it has to stop. It pulls into the pit.
Right.
The car physically cannot be racing, while the mechanics, who are our factory workers, are rushing to change the tires, which represent our manufacturing tools, and add fuel, which are our raw materials.
Actually, that is an incredibly precise analogy for modern manufacturing. I mean, in a car race, a slow pit stop can literally cost you the entire championship.
Literally, fractions of a second matter.
Exactly. Every single second that car is stationary is lost time. The mechanics train endlessly to make that stop as fast as humanly possible. And factory operators are doing the exact same thing during a changeover.
Yeah, let's ground this F1 pit stop idea in the physical reality of a factory. The scenario given in the text is shifting from producing a 500 milliliter plastic bottle to a 1 liter bottle. The text notes that molds, machine settings, and labels must be changed.
Right, so let's break down that workplace vocabulary. Let's start with molds. A mold is a heavy, hollow container used to give shape to hot liquid material, like plastic or metal. If you want to make a bigger bottle, you physically have to unbolt and remove the heavy metal mold for the small bottle, crane it out of the way, and install a massive new mold for the large bottle.
But it isn't just swapping physical hardware, right? You also have the machine settings. This means the digital brain of the machine needs calibration. The speed in the conveyor belt, the heating temperature for the plastic, the volume of air injected to blow the bottle, all of those parameters have to be manually reprogrammed for the new 1 liter size.
Yeah, and finally, the labels. The packaging materials themselves must be swapped out at the end of the line, so you can start to see the cascading effect here.
Oh, for sure.
A single product shift requires physical, digital, and material adjustments across the entire work area.
Which brings us back to the bottom line. How exactly does this downtime translate to the business's overall health? The text argues that longer changeovers reduce efficiency.
And efficiency is the holy grail of manufacturing. It is a direct measure of how much output you get for your input.
So what does that mean practically?
Well, if you have high downtime, your input, meaning the time and wages you are paying, is extremely high, but your output, the finished bottles, is zero.
Right.
Therefore, your efficiency tanks. Less downtime mathematically equals more efficiency.
So the problem is clear. The pit stop takes too long. Now we arrive at the solution, SMED, single minute exchange of die. So single minute means single digits. We are talking about getting this massive factory pit stop under 10 minutes. But what exactly is a die? I mean, when I hear the word die, I think of, a pair of dice in a board game or, well, someone passing away.
Yeah, it's a classic point of confusion for English learners. In plain manufacturing English, a die is a specialized, extremely heavy tool used to cut or shape material, usually with a massive press.
Wait, how is that different from a mold? We just talked about molds.
Great question. They are very similar concepts, but generally a mold is a hollow cavity. You pour liquid into like molten plastic for a bottle.
Okay.
A die is more like a giant industrial strength cookie cutter. You press a die into a solid sheet of steel and it cuts out the exact shape of a car door.
Oh, I see.
So an exchange of die is literally the physical act of removing the old cookie cutter and bolting in the new one.
Got it. It's the heavy tooling. So SMAD is a system to change that giant industrial cookie cutter in under 10 minutes. The goal is to shorten changeovers dramatically.
The choice of the adverb dramatically is important here. We aren't talking about a minor 10% improvement. SMAD is a paradigm shift.
Yeah, it's huge.
Right. Going from a changeover that traditionally takes 4 hours down to 8 minutes isn't just working a little faster. It requires a dramatic, fundamental reinvention of how the work is done.
And we should briefly acknowledge the origin of this reinvention. Shigeo Shingo, a legendary Japanese industrial engineer.
For legend.
What blows my mind is that while this started in Japan as part of the Toyota production system, SMED is now a universal language. Whether you are walking the shop floor in Germany, Brazil, or the United States, if you say SMED, the engineers know exactly what you were talking about.
Exactly, because Shingo's genius wasn't just walking onto the floor and yelling at people to work faster. He gave them an intellectual framework to categorize their work. He forced them to separate tasks into 2 groups, internal and external.
Let's spend some real time contrasting these 2 words, because outside the factory, they mean something entirely, totally different.
They really do.
In everyday conversational English, internal just means inside, like an internal organ. External means outside, like external pressure.
Exactly. But on the factory floor, those definitions are thrown out the window. In SMED, internal means the machine must be stopped.
It's mandatory.
Right. The task is internal to the downtime window. You physically cannot reach your hands in and unbolt a mold while the machine is aggressively stamping out plastic bottles. It's impossible, and it's lethally dangerous.
So internal equals stopped, and external means the machine is still running.
Yep.
The task is external to the downtime window. You can be walking over to the storage rack, fetching the new heavy mold, cleaning it off, and positioning it safely right next to the machine, all while the machine is still busy making the last batch of the old bottles.
This simple categorization is the absolute core of the method.
You know, I have another analogy for this that I use to visualize it. It's like cooking a complex meal. Think about the internal tasks in cooking. These are things you can only do while the pan is actively on the fire. You have to physically stand there and stir the sauce so it doesn't burn. The cooking process is happening, and you're tied to it.
I'm not sure cooking is the best comparison here, though. I mean, a home chef making soup on a Tuesday night isn't racing a stopwatch the way a factory line is. If the onions aren't ready, the chef just waits. A factory bleeds $1,000 a minute if it waits.
True, a home cook isn't sweating over downtime costs. But think about professional commercial kitchens. Think about the dinner rush.
Okay, yeah.
Professional chefs use a concept called mise en place. They do all the external preparation before the stove is even turned on. They wash the vegetables, chop the onions, and measure the spices hours before the restaurant opens.
Right.
If a line cook waited until the oil in the pan was smoking hot to start frantically chopping onions, the kitchen would collapse into chaos. SMED is basically factory mise en place.
Ah, okay. The mise en place comparison works perfectly. It is ensuring that every single tool, every wrench, and every material is prepped, measured, and positioned before you hit the red button to turn off the machine.
But implementing this is where the real struggle happens. Once you have identified these tasks, the method tells us to convert internal tasks into external tasks.
Right. To convert means to change the fundamental nature of something. You are taking a task that used to cause downtime and finding a clever way to do it while the machine is running.
And this is where you run into human resistance on the shop floor. I mean, imagine a veteran machine operator who has done the changeover the exact same way for 20 years.
Oh, yeah. The habit is so strong.
Right. They usually wait until the machine stops, and then they go walking across the massive factory floor to the tool crib to find the instruction manual and the wrenches they need. That walking time is an internal task causing massive downtime.
And converting it to an external task sounds so simple on paper. Just grab the manual and the wrenches an hour before the changeover happens. Bring them to the machine while it's running.
Exactly.
But breaking those deeply ingrained human habits, changing that we've always done it this way mentality, is the hardest part of SMED.
Which brings us to the final and arguably most satisfying step. Once you have moved everything you possibly can to the outside, you are still left with some internal tasks that require the machine to be off. The text says we must streamline and simplify the remaining internal tasks.
Streamline is a brilliant vocabulary word. Think of its literal meaning. A stream is a flow of water. If a river is full of jagged rocks, branches, and debris, the water crashes into them, slows down, and creates turbulence. To streamline a process means to remove all the rocks. You eliminate the friction so the work flows smoothly, quickly, and efficiently.
And the text gives us incredibly practical examples of how to remove those rocks. It mentions using quick-release clamps instead of bolts. We all know the universal frustration of dealing with bolts. Using a threaded bolt is like trying to tie your shoes with extremely long, stubborn laces. You have to thread it carefully, twist it endlessly with your fingers, grab a wrench, and tighten it down. It takes forever.
And in manufacturing, forever means lost profit.
Yeah.
But a quick-release clamp, that is like a Velcro shoe. You position the mold, you pull a single metal lever, it snaps firmly into place, and you are completely done in 1 second. Snap.
That's amazing.
That is the essence of streamlining. You took an internal task that required 2 minutes of twisting a wrench and crushed it down to 1 second.
The text also explicitly mentions standardizing tools. This means making things uniform across the entire facility.
Now, play devil's advocate for me here. If standardizing tools is so great, why wouldn't a factory just do this immediately?
Because it requires upfront investment. Imagine a factory with 50 different machines, all bought in different decades, using different size bolts.
Oh, wow.
Right. To standardize, the factory has to spend money today to buy hundreds of identical bolts and modify the machines to accept them. Management hates spending money, but the return on investment, the ROI, is massive.
Right, because if every single machine uses the exact same standardized bolt, the worker only needs to carry one single wrench in their pocket. They don't have to drag a heavy, disorganized toolbox around.
Exactly. It saves physical energy, but more importantly, it drastically reduces cognitive load. Cognitive load is the amount of mental effort being used in the working memory.
Okay, tell me more about that.
During a high-pressure changeover, you don't want your workers stressed out, stopping to think, wait, is this a 14-millimeter wrench or a 12-millimeter wrench? If the tools are standardized, they don't have to think. They just act.
Wow, that makes a lot of sense. And the text mentions one last technique, using preset adjustments.
This functions on the exact same principle of reducing cognitive load. Without preset adjustments, a worker installs a new mold and then has to manually calibrate the machine by turning a dial, guessing the pressure, running a test piece, seeing it fail, and adjusting the dial again. It is pure trial and error.
A preset adjustment removes the guessing entirely. The dial literally just clicks firmly into a pre-marked slot explicitly labeled 1-liter bottle. Done. No testing required. The machine is ready to run immediately.
Which naturally leads us to the concluding sentence of our source text. By applying SMED, manufacturers reduce downtime, increase productivity, and respond faster to customer demands.
It all circles back to the bottom line. You clear out the internal friction so you can serve the customer faster.
Let's synthesize our core takeaways from today's deep dive. We have unpacked a lot of crucial workplace English, but 4 terms stand out as absolutely essential for anyone operating in this space.
Yeah. Number 1 is our anchor word, changeover. This is the physical, coordinated process of transitioning a machine or production line from making one product to another.
Perfect. Number 2 is downtime. This is the painful period when a machine is not producing anything, it is silent and costing the company money, usually due to a changeover or an unplanned breakdown.
Number 3 is SMED, or single-minute exchange of die. This is the Shigeo Shingo system, designed to reduce those changeover times to under 10 minutes by categorizing the work.
And number 4 is streamline. To systematically alter a process so that it flows more smoothly and quickly, removing any unnecessary steps, friction, or obstacles.
If you can confidently use those 4 words, you will dramatically improve your ability to communicate on any factory floor in the world. You are learning the universal language of efficiency.
I actually want to leave you with a final thought to mull over something you can take with you even after you leave the factory floor.
Oh, I love this.
We've spent this entire time talking about how SMED was engineered for giant multi-million-dollar industrial machines. But the core philosophy behind it, the act of brutally separating internal and external tasks, is completely universal.
Oh, I see where you're going. Applying factory logic to daily life.
Exactly. Ask yourself,
Yeah.
can you apply the SMED to your own personal routines? Look at a daily task that always takes you too long or always feels stressful and chaotic. Let's take getting ready for work in the morning. When your alarm clock goes off, your personal downtime begins. Every single minute you spend frantically getting ready is a minute you aren't doing something productive or relaxing.
That is so true. So standing in front of the closet, staring blankly at your clothes, trying to decide what to wear while the clock is relentlessly ticking, well, that is an internal task. You are burning daylight.
You are causing your own downtime. Making your lunch, frantically searching the house for your car keys, if you're doing those things in the morning rush while the machine of your day is trying to start, they are internal tasks.
Right.
The SMED challenge is this. How many of those chaotic morning tasks can you convert to external tasks the night before?
Right. Can you lay out your clothes, pack your lunch in the fridge, and put your keys on the table while your evening relaxation machine is still running?
Exactly. Streamline your morning routine using industrial engineering. See if you can get your morning changeover into the single digits.
That is a brilliant challenge. Think about your internal and external tasks this week. We hope this deep dive has given you some valuable vocabulary tools to use on the shop floor, and maybe a new perspective on your own workflow. Keep looking for those quick-release clamps in your own life, and keep learning.